Now, we're working with angles, and we're going to learn angle relationships. And I will try to make this as nice and neat and uniform as possible and wrap it in a pretty little bow for you. But you have to study, you have to memorize. Okay. There will be a total, not today, but in total, there will be 7 angle relationships that we will learn. 7 words that can be used to describe the relationship shared by a pair of angles. Today there's going to be 2 of them. And all of those 7 will either lead to one of 2, I don't want to say equivalencies, but how can I say this? It will lead to the angles being one of 2 things. Every relationship will either end up being congruent. What does congruent mean? No, what does congruent mean? Equal, the same, fine. Same, equal, good. So either congruent or supplementary. What does supplementary mean? Supplementary. What does supplementary mean? It's one of the properties that we studied. It was on the thank you, adds up to 180. So 2 angles share some type of relationship. There's going to be 7 of them. There's going to be like how you say cousin and uncle and like relationships. So there's going to be 7 of those. But each of those 7 will either lead to those 2 angles being congruent or being supplementary. 4 are congruent, 3 are supplementary. Today, though, we only learn 2 relationships because we're dealing with angle relationships that are at a single intersection. What I mean by that, let's throw this up here. Where are you, Mr. Mouse? There you are. Okay, before I'll just squeeze it in up here. If I draw up 2 lines, I'll just squeeze it up here real small. If I draw 2 lines that cross once, one single intersection, how many angles are created?
4.
4. So that's what we'll be dealing with today, and I believe it's also scheduled for tomorrow. Whatever we don't finish today, we finish tomorrow. But what are those possible relationships with those 4 angles? No more. Like, yeah, we'll have some on this page that have less than 4 angles there, but the thing is that they're only meeting once. There's only one intersection that we're studying, not multiple intersections. Okay. So this is a little bit of a review. We saw this before, so I'll go through this fast. I'll spend more time on the stuff that is new. Complementary angles. We talked about that before. What does it mean when 2 angles are complementary?
I mean,
2 angles add up to 90. Okay, so here in green, you'll see that I've paraphrased so that if this looks like a foreign language to you, just how can you say it in plain speak? 2 angles that add up to 90 degrees. And here are some examples of complementary angles. Why is this first example here? Why do those add up to 90? Because of the little box. Okay, together they make a right angle. Right? Now this is actually also a word that we've actually seen before, but we're gonna focus on today. It's one of the focus that the angles are adjacent. They meet, they're right next to each other. Okay, so they're adjacent angles that happen to add up to a 90 degree. These 2 angles happen to be they're not adjacent, but they are complementary because 50 plus 40 is 90. Those are the other 2. Yeah? You double checking that? Okay. If Jamal says so, then I agree. Okay, supplementary angles. We already talked about that. 2 angles that add up to 180. This first example here, those angles happen to also, how many angles do you see there? 2. Okay, angle 1, angle 2. They have more specific names. You know, EFH, HFG. But there are two angles there, and those two angles are adjacent. They're next to each other. They share a common vertex, but they also add up to a straight line. And how many degrees are there in a straight line? 180. The other two angles are not adjacent, but Jamal, you can double check. 100 plus 80? It's 180. Okay. Now here's your first angle relationship for the day. Adjacent. That is the first one of 7 angle relationships. When we have adjacent angles, that means the word adjacent just means that they're next to each other, right? Now, where the relationship is going to come in is back where I drew that picture of intersecting lines. How many angles did we say there are here? 4, right? So, which pairs of angles would you say there are adjacent?
2.
Which pairs? Give me the pairs of angles. 1 and 2, yeah, those are adjacent. 4 and 3, 3 and 2. 1 and 4. There are 4 sets of angles that are next to each other. So what we will learn is that in this scenario where we have one intersection, where 2 lines intersect and go through each other, adjacent angles will always be supplementary. Adjacent angles are supplementary. I've printed out the notes for you, but I've left you plenty of space where you can write your own stuff in there. So you can, whether it's drawing arrows or writing them in, say that when you have a single intersection, adjacent angles will be supplementary. After this slide, it's just going to be examples. Example after example after example. Okay. Here's your second angle relationship for the day. Today we're only going to do 2. Here's the second one. I will now, oh look, perfect. They've done it for me. Fantastic. Look, this is what I wanted. So here they've drawn a single intersection. Vertical angles are across from each other. Can you tell me which pairs of angles there are across from each other? Well, I'm not even going to get complicated and have it say AED and then BEC, because if you're going to get confused. Let's just go by numbers. I numbered them for you.
1 and 4.
1 and 4 are not vertical. They're not.
1 and 3.
1 and 3 will work?
4 and 2.
Yeah, 2 and 4. Okay. Now, what are we going to learn about vertical angles? I don't know if I have it written somewhere else here on this slide, but I told you every relationship is going to lead to one of 2 outcomes. One is that they're possibly supplementary. What was the other one? Either supplementary or, did I ask you at the beginning? It's on the video. Starts with con and congruent.
Congruent.
Congruent, yeah. Which one do you think vertical is going to be? Supplementary or congruent? It is congruent. Vertical angles will always be congruent. The phone is still out. It's still not being used. Just put it away then. Put it away. Okay. A linear pair. A linear pair is just another way of saying that angles are both adjacent and supplementary. I won't spend a lot of time on this because this was part of the first unit. This was some of the vocabulary we learned on the first unit. Harley knows. He likes linear pairs. Okay. Now these are just a couple things to throw in here. What do you see on the diagram? Okay, well, what else do you see that I've now drawn like 3 times already, and now they've drawn it for me? 4 angles. Okay, well, 1 intersection, which means, yes, there's 4 angles, right? So, in order to sum all this up, basically what all this tells you here, if you read it, is that if you have a single intersection, but one angle is 90, if you have one right angle, all 4 angles have to be 90 degrees. Which would mean that all of the angles are not only congruent, they'd also be supplementary, because what's 90 plus 90, Jamal? 180. So in this one instance, Adjacent angles are not only supplementary, they're also congruent. Vertical angles would not only be congruent, they'd also be supplementary in this one scenario, where you have all 90-degree angles. The other nice thing about this graphic is it shows you the symbol for perpendicular, which I think we discussed already, but just in case you forgot it, an upside down T, that's the symbol for perpendicular. You see how they drew it here? They tell you line XZ is perpendicular to line WY. I. Okay, this last one. Here, I can try to get some of these out of the way to show you what this means. This will make more sense once I get rid of this stuff. Okay, what we see here is a perpendicular bisector. We already know what bisector means. What does bisector mean?
In half.
Cuts in half, right? So we learned of two different types of bisectors in the first unit. One was a midpoint. A midpoint cuts a segment in half. The other one we learned about was an angle bisector. Okay. What this is telling you is if I have a segment, which one of these is my segment? My line segment. Which one has a beginning and an end? AB, right? So if I get this segment and cut it in half, like even though they don't give it a name, right here is my midpoint. And if I draw a perpendicular line through that midpoint, what that's telling me is that any point on this line, they drew one at P, but I could put any point I want on that line that's going through, and any of those points will always be the same distance from A as it is to B. It doesn't matter where I put it. If I draw a line through the middle, any point on that line will be the same distance from those endpoints. So now when I put everything back the way it was, maybe it'll make a little bit more sense. So like they put P on there. What this is telling you is that that imaginary distance from P to A is the same thing as from P to B. Since they already used one slash to indicate that this point was the midpoint, and if I want to still show that AP is the same as PB, I use two slashes. Because if I would have used one slash, what I'm indicating is that now all four of those are the same. I can't do that. So I use two slashes. But wait, but Mr. Romero, how about if you would have done three slashes? Would that, yeah, that's fine. You just can't use the one again because anything I put one slash on would mean that it's the same as those first two. Any other questions there? Andrew? All right, so let's start the examples then. Whatever we don't finish today, we'll finish tomorrow.
Oh, wait, I didn't have a question.
And these, yeah, you have a question, right?
So, it's like everything that's under, nothing goes under that line, like that you do, for the middle.
Nothing goes under the line.
I mean, like,
Here, watch.
what I'm trying to say.
Here, let's say that there was a point here. What this property is telling you, let's call it Z for Zyra. All right. So Zara. Okay, so for Zara, what this is telling you is that that point Z is going to be the same distance from A as it is from B. If I wanted to mark it on the diagram, I've already used one slash, I've already used two slashes, so let's just go ahead and use like three slashes. And that would be true for any point, even if I put the point down here somewhere that's not even on the board. As long as it falls on that line, it's going to be equal. If you have to focus, like let's say there's a limited amount of attention that you have that's available to be given right now, and you can only pay attention to certain things on the slide. What do you have to know? What is the main idea? Because I throw in a couple extra things that just say you never know when they come up later. You know, just to say, hey, look, I've shown it to you. But the most important thing is adjacent on one intersection means
Supplementary.
supplementary. Write it down. Very good. Vertical means
Congruent.
congruent. That's it. That's the most important part of the first line. Adjacent, supplementary, vertical, congruent.
Good job.
And then really anything else might be applied algebra. You're gonna TBW. We're gonna throw it back to algebra here. So all these examples are also on your printout, so you can follow along at home. That's the writing much. Angles 1 and 2 are complementary angles. Angles 2 and 3 are supplementary angles. Give the measure of angle 1. Sorry, given the measure of angle 1, find 2 and 3. Okay? So let's see. There's 4 different problems here we're going to work out. So measure, that little m means measure. So whenever you're going to talk about degrees, you should put the little m in front of the angle symbol. So measure of angle 1 plus measure of angle 2 gives me, if they're complementary, what's that going to give me? What do those two add up to? 90. Measure of angle 2, oops, that's not 2. Measure of angle 2 plus measure of angle 3 are supplementary. So what does that give me? 180. Okay. So what they're gonna do now is they're gonna give me a basically like a chain to follow, because then they want me to find 2 and 3. So like they're gonna start me with 1, and I'm gonna use 1 to find 2, and then I can use 2 to find 3. Let's do this. Let's use our algebra skills, which we became excellent at last year, to try to arrange these to our advantage. If they give me angle 1, I only have one equation that has angle 1 as part of it. Which one is that? The first one. What's the only other angle that's there? Huh? 2. So that would imply that on every single one of these, I'm going to have to find angle 2 first. Not because 2 comes after 1, but because if they're only going to give me 1, I only have one statement of equality that has a 1 in it. That's the first one. So I'm going to use that. But since I want to use it to find 2, let me do myself the favor of getting that measure of angle 2 by itself. If I want to cancel this measure of angle 1, pretend like if this was algebra, and I wanted to get it out of there, how would I do so?
Subtract.
Subtract, good. It's the opposite of adding, subtract. So minus the measure of angle 1 minus the measure of angle 1. So I could then say that on every single one of these, on all 4, the measure of angle 2 is going to equal 90 minus the measure of angle 1. On every single one. Okay. Then once I have the measure of angle 2, I can now use the second equation to find the measure of angle 3. So it means I would want to get that one by itself. What would I do to get measure of angle 3 by itself?
Subtract.
Subtract what?
Measure of angle. You say you want to get, yeah.
I want to get 3, so measure of angle 2. So I would then cancel that out and then say measure of angle 3 is equal to 180 minus the measure of angle 2. So now that I have everything set up, this is going to make, like the worst thing I might need is a calculator. So let's do number 1 first. Measure of angle 2 is, well, if measure of angle 1 is 80, what's 90 minus 80? 10. Bam, 10 degrees. Done. Now that I know that measure of angle 2 is 10 degrees, measure of angle 3 is, we'll plug the 10 in there. What's 180 minus 10? 170. Now I'm going to try to print out the notes for you, so you have the notes for tomorrow. And if you choose to do the written assignment, that's the written assignment. But the thing is, it'll be due Friday. So we have 2 days this week. So if you want more time, you got to do the digital. Any questions there? Okay, number 2. Number 2, they give me a 33. So what would the measure of angle 2 be? If 1 is 33, what's 90 minus 33? I see you're calculating. What's 90 minus 33?
90 minus
33.
57.
Good, it is 57, yeah.
I said that.
For real?
And then now that I know that 2 is 57, to find 3, what's 180 minus 57?
123.
It should be 123. Do I need to do the last two, or do you get the hang of this?
You could
You
do
just,
last.
yeah, do last.
Okay.
If you wanted to.
No, it's just that it's not the most
90.
important thing, but okay. For number 3, it says 72.
Mhm.
So how do you find angle 2? What's 90 minus 72?
Oh, so if it's more or
18.
if it's
Angle 1 is I'm basically substituting. I'm saving myself some stuff, but I'm plugging in the 72 there. What's 90 minus 72?
no, this is what I'm saying. Like if it's like more than 180, then we like subtracting out 180.
No. Doesn't matter what it is. Whatever
Wait,
whatever
so how do
whatever it is, I'm plugging it in. I only have one equation that has angle 1 in it.
Oh,
So whatever, and they're always giving me angle 1. So get whatever they give you, plug it in there first. Take it away from
okay.
90.
So we just did that to know that it's just.
So no angle 2. I'm first looking for angle 2. Now that I know angle 2, what's angle 3? Get that 18 and plug it in to angle 2. What's 180 minus 18? 162. Joseph, you got the same thing? 162? Jamal, you still need me to do the last one? Alright, let's do that one verbally. What's 90 minus 7?
83.
It is 83. Very good. So angle 2 would be 83. What's 180 minus 83?
Oh.
97. 97. Angle 3 would be 97.
Oh.
Here we go with some of the more important ones now. Yeah, applied algebra. I told you what the most important angle relationships were, but they're not the only ones. What angle relationship is being? Okay, we do have adjacent angles, but we don't have the one intersection thing. So, can you tell me what the relationship is when two angles end up adding up to 90 degrees? Complementary. We're not going to really use that as much, but you still need, if anything of this is review. This is something that could have shown up on the last test. So, the reason why I threw this in is because structurally you have to get used to understanding how geometry can be applied algebra. The algebra part comes in, look, in algebra, I want to know what x is. Isn't that what the directions tell me to do? Actually, no, they want me to find both angles. Perfect. Okay, so I have to find what these two angles are. But I can't find what those angles are without knowing what x is. How do you find an unknown? In Algebra 1, how did you learn to find an unknown number? Equation. You have to have an equation, which in this case you're going to have to write it, and then you solve it, right? Well, there's the applied algebra. We have to know how to use our geometry properties to be able to write that equation. Yes, Stefan. Equal. Means the same. Equal.
So.
But these aren't congruent. These are complementary.
So complementary means 90.
Means adds up to 90. Yes. This is not going to be a very common relationship. I didn't even count it in the 7. Remember I told you there's going to be 7? Complementary really wasn't one of them. But it's still one that you should know. So, again, so what I'm looking to do now is write an equation. Think of it like a word problem. I need to write an equation where I'm adding two angles, and at the end, those two angles are going to give me 90. Okay, so give me an expression for each angle. Let's go with the first one. What's an expression for ABC? What can I plug in for ABC? 2x. What can I plug in for CBD?
3x.
And now it's just taking it back to algebra 1. This is the only new part. You're right, 2x plus 3x is 5x. So I would say 5x minus 10 is equal to 90. plus 10 plus 10.
10.
Zara, you start singing when you saw the equations?
That's not tricky.
Divide by 5. So my 3 steps so far have been combined like terms. 2x and 3x gives me 5x. Then I added 10 to both sides. And then finally I divided by 5. And so x gives me? So x is 20. And you're like, yes, success, I am done. Well, if they would have only asked for x, then we'd be done. But they didn't. They asked for the measures of angles ABC and CBD. So, the measure of angle ABC, since ABC was the 2x, before I didn't know what x is, but now I know. Oh yeah, it's 2 times 20, which that gives me 40 degrees. Do I need to plug in the 20 to find the next one? No, you don't. You could, but you don't. Because if I know the angles are complementary, which means you have to add up to 90, and I now know that one of them is 40, what's the other one going to be? 50, yeah. Jamal, you want to double check?
Wait,
Make sure 40 plus 50 is 90.
how is it 50?
Because remember, the angles are supposed to add up to 90.
But wasn't the x 20? So, like, one
Okay,
side-
fine. Let's do it that way. That's fine. There's more than one. I just used the property to find the last angle, but let's do it with the. Let's use the x that we found. So now I'll be using 3x minus 10.
We figured that out already.
3 times 20 minus 10. What's 3 times 20? Minus 10? Still gives me 50.
Wait, where'd you get 3 from?
They wanted me to find angle CBD. That's equivalent to 3x minus 10, but now I know what x is, so I don't put an x up for 20.
ABD was equal to 20.
ABC. No. X was 20. I use this equation and the fact that they were complementary to find x.
So ABC
One-
was 20.
ABC ended up being 2 times x, which was 2 times 20. This gave me 40. 20 was just the unknown. I couldn't find any angle until I know what x is. I found out x by writing an equation. Now that I know what x is, I plug them back into each angle to figure out what each angle is. You still seem confused.
I'm lost. So remember how
Do you know what complementary means?
Yeah.
Okay. So the definition of complementary is what allowed me to write the equation. I can tell by this diagram that these two angles that are being shown, ABC and CBD, are complementary. So I wrote that as an equation. That the first angle, which is 2x, plus the second angle, which is 3x minus, I don't know what x is yet. I don't know. But I do know because since I know what complementary means, I do know that if I add them, I get 90.
Wait, so what are you trying to find? What's the final answer?
Well, at the end, the final thing I'm trying to find is what is the measure of angle ABC and CBD. But I can't do that if I don't know what x is. X is an unknown number. All I know right now at the beginning, not at the end, at the beginning, I know that ABC is going to be 2 times some number. I don't know what that number is. All I know about CBD is that it's 3 times some number, and then I take away 10. But I don't know what that number is. So the first thing I did is I used my investigation skills to figure out that that unknown number was 20. Now that I know that unknown number, now I can plug them back in, and I found out that ABC was 40 and CBD was 50. Zara still? No? All right, let's try another one.
Yes.
Okay, now we're starting to work our way towards our relationships a little more, because these are also adjacent angles, but these are supplementary. Stefan, just like with the last one. Look, I want to know what these two angles are, but in order to know what ABC is, I need to know what x is. In order to know what CBD is, I need to know what x is, and I don't know what x is. But what I do know is that if you put two angles together that make a straight line, they're supplementary. And what does supplementary mean? That I can add them, and I should get 180. But what am I going to add? Kyla, no. No, calculator. Bring a calculator. I don't want phones. No phones.
Minus 22.
Yeah, no phones.
8x.
13x.
So 5x minus 22 and 8x plus 46.
13x.
So that does give me 13x.
Negative 22.
And then negative 22 and 46 is 24. Plus 24 equals 180. Oh, yeah, so and honest, to be honest, like when I teach geometry, yeah, okay, fine. Some people still don't know how to write the equations, but if you can go over like, if you can get over that hump and then you know how to solve the equation, that's great. Like I have kids that, it's hard enough to teach them that, but then once they still don't know how to solve the equation. So if you know how to solve the equation,
I know how to do that.
yeah. So then the only new thing is knowing how to write it. Think of it like reading a new language. So minus 24 minus 24. 13x is equal to 156, as the cool kids say.
What?
And then 13. You divide by 13 at the end. Somebody with a calculator is at 12. Jamal, you want to do it in your head?
Ain't that 13?
I think it should be 12. 156 divided by 13 should be 12. Did I get that right?
Yeah.
4 out of 5 Jamals agree that it's 12. That other Jamal is the sneaky one. No? Have I lost you yet? So now that unknown number that was a mystery to me. Thanks. You're looking out, man. Appreciate it. That unknown number that I didn't know, now I know it. So now I can plug that back in to figure out what those missing angles are. The first one, ABC, was 5x minus 22. So measure of angle A, B, C was but now I know x is 12, so 5 times 12 minus 22.
So how do you know
Did I do wrong? Huh?
How do you know which angle x is?
X is not an angle. X is part of the angle. It's an unknown part, but now it's known. So now once it's known, I'm just plugging it in. I'm getting this 12, and I'm plugging it in for here, and I'm plugging it in for here. And what should happen is when I finish, I should be able to add those two angles and get 180.
So ABC is 60.
60 minus 22, which is
Wait, don't you divide 12 by 5?
No, I want to multiply. 5x means times. 38. You okay, Zara?
No.
And then the point I was trying to make originally is for the second angle, you could go back and plug in if you want, but if I know the angles have to add up to 180, I could just say the measure of angle CBD is just 180 minus 38, whatever's left over, because I gotta get to 180. So you're just plugging it in. Well, in this case, I'm not plugging it in. I'm just taking advantage of the property that says if angles are supplementary, they add up to 180. If one angle is 38, whatever's left is going to be 180 minus 38.
But I mean, you can plug in.
But you could also plug in. Look, I'll do it by plugging in. I'll do it 8 times 12 plus 46. Let's do it by plugging in. 8 times 12 is 96. 96 plus 46 is 142. Take a wild guess what 142 plus 38 is. It's 180. Just substitute. I think I can do one more. Here. Well, actually, that's the same thing. Let me. We can go back to that one if we have time tomorrow. I want to do one that's different. Here, we can do this one here. Perfect. Tell whether these angles are vertical angles, a linear pair, or neither. Remember, vertical meant across. Linear pair is actually what we just seen the last 2 times. They're adjacent and they make a straight line together. Okay, so let's see. So angles 1 and 3. Are 1 and 3 vertical, a linear pair, or neither?
Linear.
No, they can be both.
Yeah.
They're none.
What you mean that make a whole straight line?
If you include 2. Does that say 2 there?
Oh, you have to.
Linear pair. Pair means 2 angles only. I got 3 angles there.
I didn't know you could.
Okay? So if anything, if you're gonna make a mistake, you might say vertical, but the reason why it's vertical is because it's not just 2 lines crossing. So this would actually be neither. How about 2 and 3? How about 2 and 3?
Adjacent.
Well, look, you are correct. 2 and 3 are adjacent, but that wasn't one of the options.
Linear pair.
But a linear pair has to make a straight line together. 2 and 3 don't make that entire straight line.
It's a vertical.
Neither.
It's gonna be neither.
You know what?
Here, watch. When I finish the whole thing, it'll make more sense. Okay? How about 4 and 5? Those are not vertical.
That's linear.
Those are a linear pair. Yeah, they're next to each other. They make a straight line. Those are a linear pair. Linear pair. How about 5 and 8? Those are vertical. Those are, see, 2 lines going straight through each other, and they're across, vertical.
4 and 9.
And then 4 and 9 are also vertical. Very good. That's it. Good. Okay, so we'll call it an end for today, and then we'll finish tomorrow. The 2 kids that just walked in, come and see me.
Mr.
Yes.
I had to talk to you.